So now that we know that tan of an angle gives us the ratio, how do we use this in practical application problems like this one? This particular question says find the length of Vx. Well, Vx is this line right here that we're trying to figure out. Well, first things first, notice what I have written down here. Always label the triangle first. So, okay, here we go. There's my 90 degrees, obviously. Yep, there's my poor old hypotenuse, which we're not going to use because, of course, tangent, which is tilde, means opposite and adjacent. So poor hypotenuse, we haven't used you yet, but we will eventually. Circle this guy here, put the eyeballs on it. Yep, it's staring off. Yep, at the opposite. This is my adjacent. So look what I have. If I write out tangent, tangent of the angle is opposite over adjacent. Look what I have though. This is the cool thing. I have 35 degrees. So now tan 35 degrees. Opposite. I don't have the opposite. That's my question mark. That's my unknown. So I can put that down as x. And my adjacent right here, and I got to erase this to see if that's 6.5. It is. It is 6.5 meters. Now check this out. How do I solve something like this? What do I do with it? Oh my goodness, this is crazy. Well, guess what? There's no inverse tan. The reason why there's no inverse tan, because tan of 35 is actually a number. So if you think of tan 35 as a number, here, let me prove it to you. There's my calculator, hit tan of 35, and it works out to be a number, 0.700. It's a number. So what you can do here to solve for x is something I love to do, which is called cross multiply. So you're going to take this 6.5 and you're going to multiply it by your tan 35, and that's going to give you 1 times x, which is x, and 6.5 times tan of 35, okay? And let me show you something really, really cool. Now, some important stuff you need to know. Always, always have brackets around this because your calculator will not interpret this as tan of 35, especially if you write the 6.5 next. What am I talking about? Check this out. What is the difference between tan of 35 times 6.5? Your calculator will do this. You want the tan of 35, but your calculator will do this. And that's wrong. Look, this is where the bracket is supposed to be. Right, oops, that's 6.5. You want the bracket to be the tan of 35, not 35 times 6.5. You want the tan of 35. So it's critical to have your brackets in there. So let's bring up the calculator one more time. I'm going to clear this and I'm going to show it to you. Look, you want the tan of 35 times, now again, notice I missed my bracket. So let's back it up. Let's just put our bracket there again, times 6.5. Okay, hit enter and look at that. That gives you 4.55. So x equals to 4.55. But what is 4.55? That's the opposite. This guy's 4.55, and if that's meters, that's meters. And that's how you do those kinds of questions. All right, so it works out really, really cool. But go back to your question again and notice it asks to the nearest meter. So this would actually be 4.6 meters. Be careful. Always when you're doing a question like that, you go back to the original question and find out exactly how they want you to express the answer.